Okay, a reminder that for the test, you guys don't get to use that little mole sheet that we did. You need to learn how to do this.
What if you take 5 percentage points off of our final grade?
No, you need to learn how to do it without it. Okay? So let's go over the 4 different types of problems that we've done.
I'll give you $10.
Mm-hmm. So if we're going mole of A to mole of B, that's our first one. We also have mole of A converting to mass of B. We can go mass of A to moles of B, or we can go mass of A to mass of B. So remember, this is all dealing with if we're actually changing compounds. We're starting with one compound, trying to determine how much of another compound we're using. So for this first type, if we start with moles of A, whoops. Do our little conversion, and what units have to go on the bottom? Mole of A, that way they cancel out. And once we're in moles, we can convert from one compound to another, so we can go moles of one to moles of the other, moles of A to moles of B. Where did those two numbers come from? Right, coefficients. Okay, we go from moles of A to mass of B. If we start with moles of A, what units have to go on the bottom? Mole of A, that way they cancel out. And when we're in moles, we can convert from one to another, so we'll do moles of B, then on top. And where did those two numbers come from? I'm going to just put CE, or coefficients now. But are we done? No, we need to change that into mass, so what units go on the bottom? And then we'll have grams of B on the bottom. And this is always the mass of how many moles? 1 mole. The molar mass is always the mass of 1 mole, and the molar mass comes from, periodic table. So our moles of B canceled out. We're left with grams of B, which would be the correct units. Okay, now if we start with the mass of A, so we start with grams of A. We can convert over to moles of B. What units have to go on the bottom first? Grams of A, and what units will we convert to? Of A. Right, this is a common mistake I see. Sometimes people will put grams of A on the bottom, but then they'll put moles of B on top. When you're going grams to moles, you have to stay with the same compound. You can't switch compounds with this conversion factor. So it's 1 mole, and the mass comes from the periodic table. So grams cancel out. Now that we're in moles, we can convert from one to another. So we have moles of A on the bottom. That way our units cancel out. Then we'll have moles of B on top. And these two numbers come from coefficients. Whenever you're going from moles to moles, they always come from the coefficient. Now we're left with the correct units. Okay, and the last type is going to be set up very similar to the last one. We're just going to add a step at the end. so we got to change grams to moles first. And this is the mass of 1 mole. Then we have moles of A converting up to moles of B, just like we did, and those came from the coefficients. But then what's the last step we have to do? Got to change it into mass, and what units go on bottom? Moles of B have to go on bottom, and we can go to grams of B then. And it's the mass of how many moles? 1 mole. And this comes from the periodic table. Good. Yep. If it was in kilograms, you need to change it to grams first. And how many grams are in a kilogram? 1,000. Because the mass on the periodic table is always grams per mole. So you need to get it to grams. 1,000 grams in a kilogram. Think about which one's heavier, a gram or a kilogram. Which one's heavier? A gram is heavier than a kilogram? 1 kilogram is heavier than a gram, right? So there must be a lot of grams in a kilogram. There's 1,000. Mm-hmm. If it doesn't specify what they want the answer in, it doesn't matter if it's in grams or kilograms. If it asks for an answer specifically in kilograms, then you can switch it back. Was it on Sunday morning? You know the news show they have on Sunday morning with the big sun and on CBS? No. They were talking. No, it's only on Sunday mornings. But they have, yeah, there's an old guy that does it. But they had something on the metric system versus the English system, and we are one of 3 countries that uses the English system. I didn't know that we were that. It's like us and Burma and some little country in Africa. Everyone else uses metric. Yeah. Yeah. It is. We should switch to the metric system. It would be hard to convert everything, but once everything's converted, be a piece of cake. You don't have to remember 12 and 3 and 6, and I don't know what all the numbers you have to remember. But I thought that was interesting. They're one of 3. I didn't know we were the only one of 3. Oops. Okay, next one we have determining the limiting reactant. So this is what we did last week. What's the difference between limiting reactant and excess reactant? Okay, limiting, you run out of it first. It runs out first. Controls. Amount of product produced. Oops. Actually, maybe I'll change to blue. What about excess? Not completely used up. So how about we just do an example problem? So let's say we have sulfuric acid and aluminum hydroxide reacting. So sulfuric acid is H2SO4. Aluminum hydroxide, Aluminum has a 3+ charge. Hydroxide is a -1 charge, so this is our formula. You guys will be able to use a periodic table and ion sheet. I don't think we used anything else, did we? What's those two? No, I'll have one for you. Ions? I'll have that for you too. This is a double displacement reaction, so we're going to get aluminum sulfate. Aluminum sulfate is a 2- charge, so we'll have this as our, that's going to be our formula, because this was a 3+, a 2-, so we crossed the charges. Plus H plus OH would be gives us H2O, water. So to balance it, we need 3 sulfates. So I'm going to put 3 here. We need 2 aluminums. So now let's check our hydrogen and oxygen. There's 6 here, plus 3 times 2 is 6. So a total of 12 and 6 oxygens. So I think we can just put a 6 there. That should be balanced. So let's say there's 30 grams here that react with 25 grams of aluminum hydroxide. So that's what the problem would tell you. You have 30 grams of sulfuric acid reacting with 25 grams of aluminum hydroxide. What's your limiting reactant? What do we do?
Aluminum hydroxide.
Not necessarily, right? So you're going to just pick one of them. And Valley says, let's pick 30. So you could start with 30 or 25. Doesn't matter. So if we start with 30 grams of sulfuric acid, we need to convert to see how much of this other reactant do we need to react all 30 grams of this sulfuric acid. And let's see if we have that much available to us. So 1 mole of sulfuric acid, 97.0, 97, that's a 9.07 grams. Yep, that would be the mass from the periodic table. Then we need moles of sulfuric acid on the bottom and moles of, we're trying to look at the other reactant, which is aluminum hydroxide. What numbers go here? Yep. Our coefficients. So for aluminum hydroxide, we have a 2. For sulfuric acid, we have a 3. So a 2. Oh my goodness. I got 2/3. And then we need to convert that back into grams. Since our number here is given to us in grams, it's going to be easier to compare grams. So we'll want to convert it back over to grams. I have 78. And cancels, and what do we get here? $16.07.
Where'd you get the 78 grams?
Periodic table. So add up aluminum plus 3 oxygens plus 3 hydrogens. And this would be aluminum hydroxide. Now this is how much is needed, right? We need 16.07 grams of aluminum hydroxide to react with the 30 grams of sulfuric acid. how much aluminum hydroxide do we have? We have 25 grams, right? So do we have enough?
Yep.
Yes. So does that make it limiting? No. That makes that one excess. And the other one has to be limiting, which means sulfuric acid, so 4 is limiting. Yeah, 30 and 25 would be given. So this is a good example of you can't just pick the one that has the smallest number, because it all depends on coefficients and molar mass also.
Yeah, but the one with the smaller number was.
No, the smaller number is not limiting, it's excess. Yep. So then another question that it could have is which one's the excess? That would be aluminum hydroxide, yep. And how much excess do we have? How would we figure that out? Yep, so we have 25 grams and we use up 16.07. So we're going to subtract those two, and that would give us 8.93 grams would be left over of aluminum hydroxide. Okay. So now, going on to the percent yield problem, we'll still use this equation in this problem, I think. That way we don't have to recalculate stuff. But what is our limiting was 30 grams of H2SO4. What is the equation for the percent yield? Nope. Times 100. Yep, to get a percent yield. And usually you'll be able to calculate the theoretical yield using your limiting reactant. So either the actual yield or the percent yield will have to be given to you, depending on the problem. And then you'll solve for the other variable. So let's say in that last equation, that same reaction, they tell us in lab you actually produce 30.1 grams of aluminum sulfate. So that's our actual. Do we know our theoretical yield? No. Can we find it? We start with the limiting reactant because the limiting reactant is the reactant that limits the amount of product produced, right? So we need to start with our limiting reactant, which was 30 grams of sulfuric acid. And we need to convert to how much aluminum sulfate can we produce. We'll want it in grams since our actual yield is in grams. So we already, 97.07 was our molar mass of sulfuric acid. We already found that. Okay. Oops, not one. But we'll want moles of sulfuric acid on bottom. And then we're going to convert to moles of aluminum sulfate now, because that's what the compound that we're looking for, the product that we're looking for. And this was a 3 and 1. Is that what the coefficients were? For aluminum sulfate? I think it's 1. Aluminum hydroxide was 2. Okay, so this cancels. And then we need to change back to grams. So 1 mole of aluminum sulfate. I have 342 written down. So you take 2 aluminums plus 3 sulfurs plus how many oxygens do we have? We have 12 of them, right? Or you could find sulfate's mass, just SO4, and then multiply that by 3. Either way. Okay, moles of aluminum sulfate cancel. And we're left with that. So what's our theoretical yield? So this is the maximum amount that we could find, that we could produce. Anyone have it? 35.35 grams of aluminum sulfate. So that is our theoretical yield. That's going to go here. So if we have this other actual, we'll take that and divide by the 35.35 grams of aluminum sulfate. Multiply by 100. 85. So you have an 85% yield. If you have decimal, that's fine.
Where'd you get 300?
Periodic table, yep. Okay, questions? I mean, there's not a lot of, there's only 3 things that we did, but that's just a lot of math, a lot of remembering the steps.
What's after this?
What is after
Go
this?
back to 1,007.
I think we have a little easier chapter after this one, yep.